Hello, this is Patrick at OneCNC West, and what we're going to do in this training video is start to apply toolpath for the main spindle. Now, in our last video, remember that we created two different layers. We have a main spindle layer and we have a subspindle layer. Now, just like we're keeping the geometry separate for both main spindle and subspindle, we're going to be keeping the toolpath separate between main spindle and subspindle as well. And here's how we're going to do that. When we create our machining operations, those machining operations are stored over on the right within the NC manager. Now, it's important to note that those machining operations are stored in something called a toolpath group. And right now, the default name of the toolpath group is simply called toolpath group number 1. Let's rename the toolpath group to a name that's much more descriptive. I'm going to double-click the toolpath group, and within the NC processing dialog box, let's give the toolpath group a different name. I'm going to call this main spindle. That looks great, so I'm going to click OK to that, and you'll notice now that we have a toolpath group called main spindle. All of our machining operations for main spindle are going to be located within this toolpath group. Now, while we're at it, let's create another toolpath group for the subspindle. We can easily do that by just right-hand mouse clicking, select New Group, and there's our new group, Toolpath Group number 2. Let's rename this also. I'm going to double-click the Toolpath Group, and just like before, within the NC Processing dialog box, we can rename this. I'm going to call this Toolpath Group Subspindle. I think that looks great, so let's click OK to that. Very good. So again, just like we have two separate layers for main spindle and subspindle, we also now have two toolpath groups, one for main spindle and one for subspindle. All right, we're going to start working with the main spindle, so I'm going to left click that. Another way you can activate the toolpath group is to right-hand mouse click and select Activate Group. It does exactly the same thing. All right, let's start to apply our toolpath now. If we take a look within the main graphics area, you're going to notice we can see our solid model and we can see the wireframe geometry. You can certainly apply your toolpath right now to the wireframe geometry. However, if you want to, you might want to temporarily hide the solid model so you can just see the wireframe geometry. Let me demonstrate how to do that. What you want to do is hit the letter S on the keyboard to go into select mode. And once you've done that, you can take your cursor and left-click the solid model. With the solid model selected, you can now hit the letter B on the keyboard, which is the shortcut for the blank tool. The blank tool will hide any selected geometry. And by the way, the blank tool is also accessible by this button right up here at the top of the screen. All right, so with the solid model hidden, we can now access this wireframe geometry a bit easier. Let's head over to the Command Manager and let's select Lathe Toolpaths. Here you can see a list of all the 2-axis lathe machining operations. To rough this area out, let's use the very first machining operation called Turn Face Roughing. So let's left-click that to activate it, and once we do that, you're going to notice that the cursor changes to the word Start. That's to remind us that we need to select the very start of the geometry that we want to apply the toolpath to. I'm going to take my cursor, I'm going to move it down just to the very bottom of that chamfer, and I'm going to left click. Once I do that, we're presented with these arrows. Now, these arrows determine the side that the toolpath is going to be placed in relationship to the geometry, and also the direction. Well, I want the toolpath to be on the outside of the geometry, and I want it moving in this direction, so I'm going to left click that arrow. Once I do that, the cursor now changes to the word End. So what I want to do now is select the very end of the geometry that I want to apply the toolpath to. So I'm going to left click, and once we do that, OneCNC brings up our very first dialog box. Here is where we're going to define a tool. Now, it's important to note that anytime you're doing just simple 2-axis turning, you're going to be selecting a tool from the tool library. Let me show you how to do that. To select a tool from the tool library, you can take your cursor and you can left click on the tool graphic, Or if you'd like, you can click the button called Tool Changer. Just left click it and you'll be presented with the exact same dialog box. Notice how there's two tabs. There's a Recent tab and a Library tab. The Recent tab just shows you a list of all the tools that were recently used. What we want to do is select the Library tab. Notice how all the tools are placed into different groups. Each group is a different category. For example, you've got boring tools, groove tools, drilling, part-off tools, external thread, and so on. For the roughing operation, we want to select this group here, the turn face group. And over on the right, you're going to have a list of different tools that we can select. Now, in a later video, I'm going to show you how you can edit tools and how you can also create brand new tools. But for this example, let's just select a tool that's already been created. I'm going to take my cursor and slide down just a little bit. And as I do that, I notice that we can start to see the 55-degree insert tools. Now, as I left click over each tool, we get a nice little graphic of the tool up here at the top. So as I move through here, I can find which tool I want to use. And that looks like the tool right there. That's got the proper orientation. So to use this tool, all I need to do is highlight it and then simply click OK. Now OneCNC's loaded the tool, and in the lower left-hand corner of the dialog box, we can see a description of the tool. Now let's place this in turret position number 1. That looks good. We don't need to worry about the tool offset because OneCNC is by default going to use the same number as the turret position. We also don't need to worry about coolant and work offset because the post processor is going to take care of that. However, later on, you do have the ability to change those options. Now for feed rate, you have two options. You have inches per rev and inches per minute. For this example, let's use inches per rev, and I'm using 5/1000 for that. Now for spindle speed, you have constant surface footage. And by the way, if you're using constant surface footage, you can also specify a max spindle. But for this example, I'm using RPM, and for the RPM, I've got 600. We don't need to worry about spindle direction because the post processor by default will take care of that for us. We also have the ability to add notes. This means that notes will be applied inside the CNC program for this tool. I'm not going to do that right now. I'm just going to click cancel. And then we also have the ability to change the name of the machining operation. Now, the machining operation is going to be placed up here within the NC Manager. We could give it a different name if we want to right now, but let's just use this default name, Lathe Turn Rough. All right, let's click Next on that. Now for clearance style, this controls how the tool is going to move after the machining operation. And you have different options here. I can tell you that for 95% of the time, you'll never need to change this. You can leave it alone and just set it to no move. However, later on, when you start doing more complicated toolpath, you do have the ability to tell OneCNC how to move the tool after the machining operation. For now, let's just leave it at no move. Let's click Next on that. All right, in the upper left-hand corner, you have two choices. You have Select Boundary and you have Select Contour. Select Boundary is if we want to contain the toolpath within a rectangular boundary. We don't need to do that right now. Let's just keep it simple. Let's just use Select Contour, which means that we're going to apply the toolpath to the contour that we've already selected. This is very important because this specifies the start location of the toolpath relative to the geometry. Let me demonstrate. If we have 200,000 set for Z clearance, that means that the tool is going to start 200 thousandths away from the very beginning of the geometry we selected. Remember how we first selected this chamfer as the very beginning of the toolpath? Well, if we have a Z clearance of 200 thousandths, that means the toolpath is going to start 200 thousandths in front of the part, just like that. X clearance, if I have 200 thousandths set there, that's going to tell the toolpath to start 200 thousandths away in X from the geometry. So with having Z clearance set to 200 thousandths and X clearance set to 200 thousandths, that means the toolpath is going to start somewhere about here, right where I have my cursor. 200 thousandths away in X and 200 thousandths away in Z. Just remember that your Z clearance and X clearance specify the start location of the toolpath relative to the selected geometry. All right, let's click Next on that. All right, for cut direction, we're going to use longitudinal. We're not going to be facing with this. For the toolpath direction, we're going to use auto. Auto simply means it's going to look at the direction in which we selected the geometry. Remember how we selected the geometry from right to left? Well, that's the direction the toolpath is going to be applied to. And you can see this little arrow here going from right to left. For roughing style, we're going to use normal, though you can use offset if you want to, but let's use normal for this. And if you want to, you can also output a canned cycle or a machine cycle. We're going to take a look at canned cycle, equal cut amount, retract clearance, arc entry, and overlap in an upcoming video. But for now, let's just use these values as they are. Let's just focus on cut amount. For this, I'm going to reduce the cut amount to 100 thousandths. That looks good. And for groove control, I have this set to off. That means that if we had any geometry depicting a groove, OneCNC would ensure that the tool doesn't dip down inside there. If you change this to on, OneCNC will then take the tool, look at the angles of the insert, and take that tool and drive it down into that groove geometry as far as it can go without violating the geometry. In this example, I'm going to have this set to off, but if we take a look at the geometry, you can see it's really not necessary as I really don't have any geometry that depicts any grooves. Okay, so for this example, it really wouldn't matter if it was set to off or on. Let's click next on that. Now let's take a look at these two parameters. These are very important. For example, we have cut to end and we have cut from start. Cut from start is represented down here, and this dark gray graphic represents the insert of the tool. Notice how cut from start unchecked, this is how the tool is going to start in relationship to the geometry. If I click cut from start, if I activate that, look how this changes. Now this is how the tool is going to start in relationship to the geometry. Typically, you want to have this checked. All right, so with cut from start checked, we know the tool is going to start just like this. And if you want to, you could even extend that amount. So if I click this option here, I could type in a value, let's say 100 thousandths, and that simply tells OneCNC that this chamfer is actually 100 thousandths longer, and the toolpath will respect that. In other words, the toolpath is going to start away along this vector 100 thousandths away from there. All right, so typically you either want to have it set like this or click this and add a value. The same holds true for cut to end. By default, with this unchecked, the very insert of the tool is going to stop just like that. Again, typically you're going to want to have that at least clicked to cut to end, so the toolpath will end like that. And if you want the toolpath to go a little bit farther, you can select overcut amount and type in whatever value you want. All right, I think all that looks great. Let's go ahead and click Finish and let OneCNC generate the toolpath. And there we go. You can see that the toolpath has been applied to our geometry. And if you take a look within the NC Manager, you can see our machining operation as well. All right, that's it for this training video. Thank you so much for watching, and I look forward to seeing you in the next video.